fair.
I have no idea what you're talking about.
He's lying.
Like this island of like Jewish people. Like,
0 to pi fourths of secant squared of x dx. So it's kind of an easy one. What's the integral? What's the antiderivative of secant squared? It's one of those formulas you got to memorize. What is it? Tangent. Pretty easy. The antiderivative is tangent.
Yes. Remember your identities. Just a little plug in there.
Hey, thanks, Brady.
Okay, and we're evaluating that from 0 to pi fours.
Secret identities.
Good thing I have Brady to guide me through this tribulation of life.
Okay. So now we have to do the antiderivative of the upper bound. So this is tangent of pi fourths. Subtract the antiderivative at the lower bound.
okay, this is using the fundamental theory of math, right?
Fundamental theorem of calculus.
Calculus, not just
Uh-oh. This could be a problem.
Tangent of pi
But
fours.
it isn't, so it's alright.
Oh wait, let me find what that is. Okay, it's 1.
It's just one.
Is this 4.5? How'd you
This
know
is still
that?
4.4.
I'm smart.
Okay. Yo.
Ish. Subtle.
And then
Pi fourths is 45 degrees on the unit circle. That's right in the middle.
So it's
Okay. And the definition of tangent is y over x. But right in the middle, the y and the x have the same value. So something divided by itself is 1. So tangent of pi fourths is 1. Okay. Now at 0, right here on the unit circle, the point there is 1 comma 0. Tangent is y over x. The y value is 0. 0 over anything is 0. So it just equals 1.
Oh, can all of our questions be like this?
Yeah, is that the hardest that trick gets?
No.
This is good.
Start with an easy one.
I like this.
give us the hardest one you got.
Yeah, give us the hardest one you got. It's not. You ain't down, Mr. Raw. You ain't raw to give us the hardest one you got.
Here's another little more simple one. Evaluate between 0 and pi.
I knew he wasn't raw.
2 plus cosine x dx.
How to turn it today? This equation.
27.
So.
What's the antiderivative of 2? 2 plus cosine of x. Yep.
2x
And the derivative of the antiderivative of cosine
is negative sine. No,
Square.
sine is just sine. No? Is it negative
No,
sine?
that's regular sine. It's regular sine. It's regular sine.
It's regular sine.
Look it up in your notes, you guys, if you forgot. The derivative, or the antiderivative of cosine is just sine. So this is plus sine of x. Now you guys, that plus c only occurs if we're doing an indefinite integral with no upper and lower bounds. We have an upper and lower bound, so we don't need the plus c. We just need to evaluate this between 0 and pi. So the antiderivative at pi is 2 pi plus sine pi. And then we subtract the antiderivative at the lower bound. 2 times 0 plus sine of 0.
2 pi plus
See if you guys can finish that one.
Alright, sine of pi is going to be
So the second one's 0. The sine of 0 is 0.
2 pi.
So then 2 pi plus sine pi. Sine pi is still 0. So it's just 2 pi.
2 pi r plus k.
No, it isn't.
No, okay.
You trickster.
There you
Are we recording?
It's recording.
Okay.
Oh my gosh.
So, what's the sine of pi?
I changed my name on Snapchat to Guantanamo.
Sine of pi, right here.
Yeah.
Sine of pi is
0.
0. That's X.
Sine of 0
I really like
is 0. 2 times 0 is just 0. So it's just 2 pi.
You know what this is like? This is like showing me a big lion cub that's fun to play with, and you're like, hey, Trig's actually kind of fun. And then you show me like this full-grown lion that eats me alive.
Let's try this from 0 to pi fourths of secant squared theta over tangent squared plus 1 d theta. Let's try that one.
This is easier than it seems.
You know, forget when you're writing a theta, not an x.
Hey.
Alright, suggestions.
Well,
Yeah, choose an identity that makes the
tangent squared plus 1 equals secant squared. Right?
Yeah, doesn't tangent squared plus 1 equals secant squared?
It equals secant squared.
It does equal 1.
What is that?
It's secant squared.
It's a simple identity.
It's secant squared.
Tangent squared
Plus 1
plus 1.
is equal to secant squared. Tell me secant squared.
It is, because you divide by cosine to make the sine into the tangent squared on the one side and the 1 into secant squared.
Gosh.
And then it disables the cosine squared and it makes it plus
Does,
1.
you guys, does the identity sound a little familiar?
Yeah.
Yes.
I just don't have to memorize. I figured it out using logic.
So
It is secant.
the identity is sine squared plus cosine squared is equal to 1. Okay, that's the identity. This you guys ought to memorize. Now, if you forgot all the secant squareds and tangent squareds, it's just maybe better to remember where they came from. What if we divided everything here by sine squared? What's sine squared over sine squared?
1.
And then cosine over sine
Cotangent.
is cotangent.
What is going on behind that?
1 over sine.
Cosecant.
They really need to teach them this way rather than just saying this is what they are.
So here's one of the identities. The other identity comes from divided by cosine. So if you divide by cosine squared, sine over cosine is, so it's tangent squared plus 1 is equal to secant squared. So sometimes for identities, it's easier just to remember with the derivation of them rather than memorizing them straight up. So can we use an identity?
Yeah.
Tangent squared plus 1 equals
1.
secant squared. And secant squared divided by secant squared is 1. So all this really is the integral from 0 to pi fourths of 1 d theta.
Which is just d theta.
And what's the integral of 1?
Theta.
Theta. So the the integral of 1 is theta, and then we analyze that from 0 to pi fourths. So there's just going to be pi fourths subtract 0, which is
Pi 4.
pi fourths. So at least at this point, the trig stuff isn't going to be that bad in this section.
Oh, really? It's all like this?
So I wouldn't worry too much about your trig stuff in this section.
I couldn't get that prize.
Okay? Let's move on.
Oh my
Let's do a different example.
It's the
You
line.
just have to nurture it and be a spread.
I don't like
Trig is the line cut.
I kind of want to be the line. Can I be
Everything's all about you.
Yeah.
He just can't wait to be king.
Nurture me. Nurture me, Gabe.
Alright, here we go. Here we go. Bring it back.
For example,
Okay, this is an absolute value, you guys. This one's a little bit different.
Okay.
This is an absolute value. It's not a 12.
oh, I thought it was a 12.
You wish it was a 12.
Let's first take a look at a picture of this. Draw a graph.
Okay.
Wait, but this is non-continuous, or not continuous. It's non-differentiable. Is that how
At-
you do?
At a certain point, it's differentiable, but it's differentiable other places.
But the entire function is a whole.
We're taking the integral.
I'm trying to get around having to do it. I'm sorry.
Alright.
I'm trying to be smart.
What does this graph look like, you guys?
A V.
It's a V.
Anyone should act like they're bullied. We did that.
You're on the right. You have the right
Vertex
idea.
is that -1, positive 1, 0.
Okay. Shh, 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 shh. What if it were just x minus 1? Where would that move?
1 to the right.
Move 1 to the right, but this is a little bit different. It's 2.
So it moves
X
one
minus
half
one.
to the right.
So you have to imagine it like this. How far to the right does it actually move? It only moves to the right half a unit. So move the vertex over half a unit.
Okay.
Okay.
What is that?
And what about the 2?
That shows how wide it's going to be.
Yeah, it affects the width. Okay. So we're going to go from here, we're going to go up 2 and over 1. Up 2 and over 1. And we're supposed to find the area under this curve between 0 and 2. So here's 0, and here's 2.
Not too bad.
So we need to find this little area right here. And this
We just do 1 times 1/2 divided by 2.
area right there. Let's talk about some different ways to do this. Can we just do a graphic? Can we just find the area just by using the graph?
Yeah.
Can we use something like, since it's a right triangle, you just find the area?
Let's try that. Don't we have a couple triangles? You guys remember how to find the area of a triangle?
Base times height divided by 2.
Base 1/2 base times height. So let's try the one, this little teeny one here.
Okay.
What's the base?
0.5.
So what's half of that?
0.25.
0.25. And what's the height?
1.
Okay, so the area of this triangle is 1/4 times 1.
Times 1.
Now the area of this triangle.
Well,
Well, first of all, what's the height? I know I might not have graphed this very accurately, but how do we find the height? You can plug in a 2 for x. 2 times 2 is 4. 4 minus 1 is 3. Absolute value of 3.
3.
So when x equals 2, we're all the way up at 3. So the height is 3.
My graph is actually pretty long.
Okay. The base, what's the base?
I don't know, but I'm all about it.
1.5.
The base 1/2, which is 3/2. What's half of 3/2?
3/4.
So this is 3/4.
This guy right there. This guy.
So this is 1/4 plus
1 point.
9/4.
9/4, which is
10/4.
10/4. which is 5 halves.
So it looks like our primary equation is the one up there. Our secondary equation.
Yeah.
Just wait until you did.
Thank you.
Yeah, right here.
All right.
Thank you for that all code.
Gotta switch topics here. Something called the mean value.
Wait, is that how we have to solve?
Don't we know the mean
Is
value?
that how we have to solve absolute value graph or equation?
Can we not do it algebraically?
We could do it algebraically. Do you guys want to see it algebraically?
Yeah.
Yes, please.
Maybe if
We
you
do.
just show us
What
real
would be the
quick.
best?
We just want to accentuate our learning.
Well, I mean, it kind of depends if you don't like graphing.
Are we gonna ever need this on the AP test?
Probably.
Because in
I would definitely want
free
to.
response, if they're like,
Okay, here's an algebraic approach. Okay, this you might not be as familiar with, but I want you to think about this. Think about this absolute value graph as two different functions. This part I have in blue right here, and this part I have in red right here. What's the equation of this line in blue? It has a negative slope.
negative 2x plus 1.
So it's negative 2x plus 1. That's the one in blue, sorry. Blue. Negative 2x plus 1. What's the equation of this line in red? It would go through negative 1 right here, so it would be 2x minus 1. Okay. Now, this function in blue is defined when x is less than 1/2. Because what happens when x reaches 1/2 right here? Doesn't the function switch to a new function?
Yes.
Okay, so now it's defined as 2x minus 1 when x is greater than or equal to what?
1/2.
1/2.
So we just turn it into a piecewise.
Exactly. All I've done is turn this
Solve
into a
each
piecewise.
individually.
You guys see what I've done here?
Yeah.
So rather than taking the whole entire integral from 0 to 2, we're going to take the integral of this from 0 to 1/2 of negative 2x plus 1. Then we're going to add the integral from 1/2 to what? 2 of
2x minus 1.
2x minus 1. So this is a way you could do it algebraically.
Here is the fundamental theorem of calculus for both.
You have to turn it into piecewise functions. Okay.
Wow, it's so cool how.
So just for sake of time, we don't really have time, but if you were to figure out these definite integrals and add it together, you would get
Just guys,
5/2.
how universal now.
Okay. That's an algebraic way to do absolute values. Anyway, I know that's kind of quick. Sorry.
Value theorem. No, it was well needed.
Some of you guys hinted at this 2 or 3 lessons ago. I want you to draw a graph.
Didn't we already learn this?
We did it for derivatives.
Yeah, we did derivative.
Now it's time to do it anti-style.
Mean value theorem for integrals.
C, that's one mean value.
So draw that function and let's locate it between A and B right here.
Okay, what's happening?
What would the integral of the function give us if we took the integral of this function from A to B?
The area.
Okay, so this would be the area. Now mathematically speaking, mean, you guys have heard that word before. That means like average, right? The mean value theorem for integrals says there's a value in between A and B called C. So I want you to locate C right about here. Kind of, you're on the right track, yeah.
Didn't we use the mean value theorem for derivatives to figure out that the guy was speeding with the police cars? So what if we figured out, what would this figure out for the policeman?
We'll do some applications over here in
Okay,
a second.
sweet. I'm excited.
So, draw this rectangle now that has an exact height of c. Draw that rectangle in there.
Wouldn't that therefore be a square?
A square technically is a rectangle.
Don't forget geometry, Kate.
Why? Everybody in the class are.
Okay, so you see how I've got the area of that rectangle?
Yeah. Nice looking rectangle.
The mean value theorem for integrals says there's a value c between a and b such that the area of that rectangle exactly equals the area under the curve. Okay? If we found the area of this rectangle, it would equal exactly the area underneath this
Oh,
curve.
because that piece flipped over equals that piece.
So you need to write it this way. The integral from a to b
That makes sense. So see that part that's outside the guy?
of f of x dx
I'm trying to understand how.
Wait, it just does, okay? Gosh.
it's you remember the upper and lower triangles?
Yeah? But
Yeah.
wouldn't that have to be symmetrical for that to occur?
What?
I'm talking about this all Sunday stuff.
For the picture I've drawn, it doesn't have to be.
It doesn't? Because what if it was like, it came down steeper at that point? And
It never does. No one's ever done it like that.
Cut off that edge.
You make up your own bad theories later.
Let me finish this here real quick.
Others.
This is the area under the curve. That's what the definite integral is. What's the area of the rectangle?
it is A, or B minus A,
The area under the rectangle is b minus a. That's the length.
plus
What's the height?
C, or times C,
Times
times F of C.
f of c. Okay? This is the area of the rectangle. And these are equal to each other.
Whoa, wait, you're gonna elaborate.
So that f of x dx, could that also be called f of c dx? No, never mind. Sorry, that was a mistake.
Where this really comes from, you guys, you remember how we did, and you hated this lesson, but remember how we found the area using rectangles? Some of them were inside
Oh yeah, that was
inscribed, some of them were outside the circumscribed.
Yeah.
Remember some of you mentioned, well, what happens if we found the area of the circumscribed and the area of the inscribed and took the average?
Oh, yeah.
Remember some of you mentioned that's what this is. Okay, that's pretty much what this is. This area of the rectangle will be the average of those. Essentially speaking. Okay. So here's an example of what you would see in your homework and on your test regarding the mean value theorem. Okay. Example. F of x equals x to the third. Find the value or values of c guaranteed by the mean value theorem over the interval 0 to 3. don't have to draw this in your homework or on the test, but I think since we're just learning this, we probably ought to. So draw a graph. X to the third. The graph looks something like this. You guys okay so far? That's what the graph looks like, yes?
Yeah.
So between 0 and 3, we have the area under this curve between 0 and 3, right? What we're supposed to find is a value of C somewhere between 0 and 3, so that if we drew a rectangle, let's say, for example, C was right here, and we drew this rectangle, we're supposed to know exactly where C is so that the area of the rectangle would equal the area under the curve. You guys see where we're going with this?
Oh, okay.
So we have to have a specific.
We have to find the exact value of C so that that rectangle equals the area under the curve.
Okay, so it isn't just like willy-nilly.
No, we have to find exactly where that value of C is. So the way that you start this is we need to know the area under the curve. So how do you find the area under the curve? You take the integral between 0 and 3. So we need to take the definite integral between 0 and 3 of x to the third dx. We have to know the area under the curve so we can figure out the area of our rectangle. You guys follow?
Yeah.
We need to know the area of the curve so we can figure out the area of the rectangle. So what's the antiderivative of x to the third? X to the fourth over 4. Then we evaluate that between 0 and 3. So it's going to be 3 to the fourth over 4 minus 0 to the fourth over 4. Second one is just 0. 3 to the fourth is 81, so it's 81 fourths. Okay. No, it doesn't. So let's just leave it as 81. Now let's use the actual theorem. This is the mean value theorem for integrals. Didn't we already figure this out?
Yeah.
Yeah.
This is 81 fourths, isn't it?
Yep.
Yep.
And what's b minus a?
3.
3. 3 minus 0, which is
3.
3. Okay. So 81 fourths is equal to 3 times f of c. Now what is f?
F is x cubed.
F is x cubed.
Yeah.
So what is f of c if f of x is x cubed? C cubed. So this is 81 fourths equals 3c cubed.
Oh, and we can find the values of C.
And we can find the values of c. Because what is the f function? So you just plug in c for x.
Call that check.
So divide by 3 and we get,
I don't know if that's a big source.
come on now, divide by 3.
You can multiply by 3.
Multiplying by 1/3, so we have 81 twelfths. Does that divide evenly?
Yes.
Yeah, perfectly.
You can divide both sides by 3.
27 fourths?
Wait,
Yeah.
I have a question. So to find the values of C, we have to solve it first?
Yeah.
So what's the point of finding values of C if we've already had it solved?
Solving what?
Like, because,
It's like for fun, right? Like,
well, because we find the answer to the area under the curve, right, by doing the fundamental theorem of calculus. And then we plug that into the C equation to figure out C, but then C is
We
just
don't
helping
plug
us.
81 fourths in. This is the area.
Yeah.
Okay.
Okay.
This is going to be the area of a rectangle.
Uh-huh.
This is the length of it. This is supposed to be the height.
Yeah.
So we need to figure out where C is so we know the exact height. So we have the length times the height.
We're trying to
Okay.
find the dimensions of
Of the
the
rectangle?
Yeah,
rectangle.
pretty much.
Oh.
So when the cops are
But
trying to
aren't
track
the-
down the jogger, they know exactly the places he's been.
Yeah, like he's been in this area right here.
Okay, let's keep going on this.
There.
How do we solve this? Cube root on both sides. Okay. Cube root of 27 is,
3.
so this is 3 over the cube root of 4 is equal to C.
And that's approximately 1. So.
1.8.
Is it really?
Now I probably wouldn't accept this. You can't have roots in the denominator. And I don't really want a decimal approximation either, so we need to
We need to multiply.
Oh, the top and the bottom are the cube root of 4.
with cube roots it doesn't necessarily work that way. Because if it was just another cube root of 4, then what's 4 times 4?
16.
Oh, so you need to times it by 8. Cube root of 8. That'll give you a perfect cube root.
Can't you do 4 if you use 1/3?
Or could you just
So if you do 4
Yeah.
Do 16.
Oh, maybe.
Oh yeah, 16 times 4 is 16, then 16 times 4.
Thank you. I'll do 4 times 4.
Here's really, I don't know how long it's been since you guys learned this, back in Algebra 2 maybe, but this is 4 to the first power, right?
Yeah.
If this were 4 to the third power, wouldn't we be golden?
Yeah.
So just multiply it by 4 squared. Because what's 4 squared times 4 to the first?
4 cubed.
And what is 4 squared?
16.
That's where the 16 came from. Because we wanted to equal 4 to the third. Was it ever explained to you that way?
No.
Oh, but I wish it was.
Should have been.
Gosh dang it, Miss Markley. Murr. Thanks for nothing, Murr.
Okay, so anyway, 16 times 4 is 64. The cube root is 64.
4.
Is 4. So this is 3 cube roots of 16 all over 4, and that's equal to C.
And that's approximately 1.
Okay, well, it's, I don't know, approximately that's
That's 1.8.
3 times the cube root of 16
About 1.8.
divided by 4, 1.88. Did you do that on a calculator, or did you just guess?
Yes.
No, you.
No, they didn't get it.
Scalp honor, Mr. Huff.
It's approximately 1.89.
Nope.
Okay? That's how the mean value theorem is applied.
From you?
Okay?
I hear you about it.
Here's another theorem.
Actually, it's 2. I hope that is a project.
We have 2 more theorems to get through, you guys.
Theorems?
Average value. Hey, did I say it was time to talk about a bunch of other crap?
No.
Don't remember saying that.
It's time to talk about the average value of a function.
Isn't it the measure of a function?
It comes from the mean value theorem. Okay, shh, 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 shh. This theorem comes from the mean value theorem. The mean value theorem was the integral from a to b of f of x dx was equal to b minus a times f. This was the mean value theorem. If you divide by b minus a, and then over here multiply by 1 over b minus a, which is the same as divide. You guys see what I did there?
Yeah.
Divided by b minus a over here. That cancels on the right side. And over here I multiply by 1 over b minus a. This is the average value. F of c 1 over b minus a times the integral from a to b f of x dx. This is called the average value. So for example, on that last problem we were working on, we figured out, I'll go back to it in just a second. We figured out at about 1.89. So 1.89, that's about right here. 1.89 on the function itself. Whatever this value is on the function, that's the average value of that function between the given interval. Alright?
Is that B A on the?
That's from A to B, yep. So here's how you would see it in your homework.
You better be doing your test.
Didn't know that?
Google.
Find the average value
That's a classic Google moment.
of fx equals 3x squared minus 2x between 1 and 4.
Okay, so first we got to do the whole mean thing first.
Just have to use this formula right here.
You just have to solve it with the fundamental theorem of calculus and then times it by that.
You think it's that easy, brain wash?
Okay? So,
I will. Give you my pen back.
the average value means we have to use this formula here. It's going to be 1 over 4 minus 1 times the integral from 1 to 4 of our function in a way. This is just a different way of doing it. Okay, so this is 1/3. What's the antiderivative of 3x squared minus 2x? Come on, let's go. We got to speed this up.
X cubed. X cubed minus.
So that's just x cubed
X cubed minus x squared.
minus x squared. This is the antiderivative, and we have to evaluate that from
B to A.
okay, so we have to evaluate that from 1 to 4.
So then we're going to use the fundamental theorem of calculus.
So we have this 1/3. Now we need the antiderivative at 4. That's 4 cubed minus 4 squared. And then we need the antiderivative at 1.
64 minus 16. 48.
4 cubed
64 minus 40 minus 16.
64 minus 16 is 48. And over here we have 1 cubed minus 1 squared. So this is 48 minus 0.
So 1/3, so you got 48 thirds.
So it's 1/3 of 48, which is 16.
Yeah,
Why you gotta be so rude?
Meanwhile, I gotta be so mean.
you're the lead in the play. And do this so
Yeah. So they're very similar. The mean value theorem and the average value of a function, they're pretty much the same theorem. Last thing we're doing. And this one here gets a little tricky, you guys. This last...
Whoa!
Did I erase it too quick?
Yeah.
This, what's that? Can I go back to it?
Because
3x squared minus 2x.
Cut. Cut.
Okay, this next theorem is called the second
You can see your son again. You can't just cry.
fundamental
Cut.
theorem of calculus. The second fundamental theorem of calculus.
What? There's two of them?
This is a huge section, you guys. That's why we had to take 2 days on it. We were in 4.4 last time. We're still in 4.4.
So that first one's not.
And it's taking a bit longer because of all the, hey, be quiet, hey, let's go, hey, let's get going on this. We could have been done a little while ago without all that. Okay? So the integral from a to x of f of t dt
Just like the first one.
but wait, now we're going to take the derivative
Oh my goodness.
Yay.
with respect to x.
I don't want to do this. I feel like we got
Cancel out?
The derivative of an integral are pretty much opposite or inverse operations.
Equals the function.
Okay, let me explain why it equals x right here, you guys. If this d over dx weren't here, and we found the antiderivative, you guys following very... I want you guys to try to imagine this. If we found the antiderivative of f of t, but then we had to plug in x and a into the antiderivative, wouldn't we have a function of x?
Yeah.
Oh yeah, we would.
Let me repeat that. Okay. If we found the antiderivative of f of t, that would be capital F of t. But then if we evaluated it from x to a, wouldn't we have a capital F of x minus capital F of a in there?
Yes.
But what is capital F of a? If a is just a constant, if we plug a constant into a function, don't we get a constant out of that? So this is just going to be a constant. And what happens when you take the derivative of a constant?
Zero.
That just goes away when you take the derivative of a constant. You guys follow?
Yeah.
Now, if you plug x into a function, don't you get a function of x?
Yeah.
And what happens if you take the derivative of an antiderivative? Because capital F is an antiderivative. What happens if you take the derivative of an antiderivative? It goes back to little f. That's why this equals little f of x. Okay, did you guys follow that? Kind of?
Dave, you know what?
Anywho, this is called the second fundamental theorem of calculus.
Call that bad name. He ran away. I want to tell him I'm
So-
sorry.
An easy example here of what you might see.
Hey, let's focus up.
Evaluate the derivative of the integral from 0 to x of t squared plus 1 dt.
I know the answer. But my calculation is the square root of t squared.
It's really not as hard as you think.
It's stretching my brain.
This right here is f of t, isn't it?
Yeah.
What happens if you take the derivative of the integral of f of t from a constant to x? The function pretty much stays the same except the t becomes x. So all it's going to equal is the square root of x squared plus 1.
What?
Okay.
So let's say x was a number.
Could you to really
Never mind. Never mind.
It does get a little, let me show you one of your homework problems here. This one's a little tricky.
A little triggy.
It's tricky.
Thank you, Zach.
Getting tricky with it.
Now this is capital F. Okay. What if we just differentiated this right here? Or I'm sorry, what if we just took the integral? What if we just evaluated this?
Well, that'd be t squared plus 2x.
It's going to be t squared over 2 plus
2t.
2t, and we're going to evaluate that from 0 to x. So this is going to equal
X squared over 2.
x squared over 2 plus 2x minus
0.
0. Hold up. Okay, this will just take like 30 seconds. I know we moved through this pretty quick. Do you understand where this came from? T squared over 2 plus 2t. What is this?
This is
That's the antiderivative. Now where did this come from?
I don't know.
The first fundamental theory of
I
calculus.
plugged in the x.
Ah.
And then where did the 0 come from? Now hold on, wait.
Well, what about the exercise? Go back.
Now x squared over 2 plus 2x, and then the 0 doesn't really matter, right?
Yeah.
Now what if we took the derivative of this?
Then we get big
We go back to t plus 2.
big spin.
But it'd be x plus 2.
What's the derivative of this? You drop down the 2 and it cancels with that 2, so you just have x plus 2. That's the second fundamental theorem. Shouldn't the t just have turned into an x?
Yeah, so on our homework, are we going to have to show all that work?
If it asks for it, yes.
Is that true? Is that basically saying prove this is why this
It's kind of like a proof, yeah.
At least you just knew about the cost. Why they need to
And don't stop.